assignments for you to do while I'm not here. So let's go ahead and start this up. Okay, so here we are going to do, like I said, lesson 7 about using libraries. We slightly touched on libraries last time, but that's because the bubbles didn't really have any deliverables. It was just looking at them, but that's not the case here. And so go ahead and jump into bubble 1 and we'll take a look at it. If y'all don't mind following along, that'd be great. Okay, so we've got a program here that doesn't do anything yet. We need to flesh out the function, the one function that isn't finished. Okay, so this includes the states library that we saw before, which you can see how the functions work. Well, go ahead and do that. Oh, let me put it up on the back screen. Sorry. Okay, so the states library is what we looked at last time. It's just a separate program, essentially, that is just function definitions. All of these are function definitions, and they're almost all return functions. I guess they're all return functions. Almost all of them receive a parameter. The random state function does not receive a parameter. And you can see all of the options from that library here in your functions tab. Okay, all of the library functions are given their own function block. And if you mouse over them, you can see sort of this pop-up documentation where it has the same comments that the actual library has to let you know, like, what are the details for using this function? What is it expecting as a parameter, and what is it going to return? Is it going to return a number or an entire list or a string? What else, could be anything. So what we need to do is apply the random. We want to pick a state at random. And that function is going to, new state is called when the new state button is clicked and the guess button checks against current state. So what new state is going to do is updating current state. Current state is every time you click on new state button, the value of current state is going to become one of the states picked at random, which we've written randomize or randomizing functions before, but there is a pick a state at random function built in to the library, and that is what we're going to use. And we can make sure it works by console logging the result of current state, console log, current state, and we hit run. And this is only tied to the new state button. And you can see down at the bottom, we're getting states returned at random. And that is what the, okay, so new state, when do we guess? Update the flag on the screen. Okay, so when we click new state, that's also when we're supposed to update the flag image. So we can go just to set image URL and state flag. Okay, so set image URL is just the set image property button, same thing. The image we want to set is the flag image element. And the thing we want to set it to is whatever is in the list of state flags that matches the name of the state. Okay, you can see here that the parameter is called state name. It returns the flag of a given state. Okay, state name with a string. State name has to be a string, and it returns a string that is the URL. So it's going to go directly into this. So we're going to call state library dot state flag, and we are going to send it current state. So no matter which state we use, no matter which state comes up from our random state situation, it will, I mean, it tells me the answer there. Is it case sensitive? Nope, it is. I mean, it is case sensitive, which we've seen how to fix. I'm not going to put you through that. And so there, Oregon, and so on. So we are using library functions that we didn't have to write, or if you were writing your own library, you would have already written, and you wouldn't need to write again. Okay, so that's it for bubble 1. Let's go to bubble 2. Okay, so we have a, let's see, do we have built-in libraries? We do. We have a cats library, which has these functions in it. Random breed, returns the name of breed at random. Breed image, returns the image from whichever breed you put in the parameter. And then we have returning all breeds, which is just the list, and an image chosen at random. And so all we want here is we want to, user should see a new random cat and a breed each time. Okay, so we click next button. We want to choose a random breed. Let's just make a variable because we probably will need to use it again. How about rand cat? And random cat is just going to be the result of random breed. Let's make sure it works. Console log rand cat. And we hit run. We should get a breed chosen at random. Excellent. And with this breed chosen at random, we want to set the, we want the text, right? So we want to set the text of the breed name design element. So set text. The element we want to set is breed name, and the breed name we want to set it to is rand cat, not in quotes because it's the variable. So we hit run and we should get a thing up there. Great. And we also want the image to be of that. So we can do set, well, I don't have set image, but set property. And the element is called cat image. Great name. And the property we want to set is image. And we want to set it to our image function, breed image, cats.breed image. And what do we want to set it to? We want to set it to a picture of rand cat. Okay. We are finally starting to get into what more advanced programming looks like. It looks like fewer lines of code because it's all built in. All right. Anytime we do one line, rand index gets a thing, and then we use rand index right away as the index for setting something, that type of thing, it's always going to be in a single line as opposed to the way we spread it out. But this using return functions looks a lot more like more advanced stuff. And if it were to load faster, there we go. And it works. And that's it for this one. Let's go on to bubble 3. Wait, did it say something? Oh, no. Did it have a check? It does not have a check. Okay, before exploring a library, it's a good idea to test functions with different inputs to make sure they run correctly. Okay, debug the program. So let's see what we have here. We have one function called isEven, and we have some console logs built in for us as part of our testing, and they're all going to run directly through. Nothing is inside of a function. There are, I mean, none of the console logs are. They are just calling these return functions, and they've written them as concatenating the phrase 10 is even, and then whatever the result of the function is, which the function, these are all Boolean functions, meaning they are going to return either true or false. And let's just see what happens. Okay, for the first three, is 10 even true? Is 5 even false? False. Is 2 even not? Oh, no, -2 even it is. All right, so it looks like this works, I think. It's a basic function receiving a single parameter. It's taking whatever number is sent to it, dividing by 2, and if it has 0 remainder, that means it's true. And because this orange block equates to either true or false, in the return, it sends back this entire thing equates to either true or false. And can I get it back in there without? Hey, there we go. All right. And so that the point of a return function is the entire thing turns into the result of the function, which works here. Okay, let's look at the second trio, and I'm just going to get rid of these. You don't need to get rid of those for now. Thank you. But I want the console, the debug console a little cleaner. Okay, is 10 odd false? Is 5 odd true? Is -5 odd true? Okay, so it's the same basic function, except it needs to, if it equates to either 1 or -1, if our input mod 2, meaning if whatever number we send it divided by 2 has a remainder of 1, it's an odd number. But it may also, if our input is negative, divided by 2 would end up with a remainder of -1 if it was odd. So we need to check for both. And we are returning either true or false, basic Boolean function. And you can see here in the description what it does, what the input parameter is expecting. The input parameter is called number. It's expecting a number, and it's returning a true or false based on whether or not it's odd. And the last one in between, you don't need to delete the console logs. I just want it cleaner down here. Okay. And so I think we have some issues. Is 10 between 0 and 5 true? All right. Well, that's not it. 10 between 5 and 10 true? Is 10 between 15 and 20 true? So there's an issue here. We have a function expecting 3 different parameters, the number to be tested, the low end of the range, the high end of the range, and it's going to return either true or false because this entire block is going to equate to either true or false. So we are sending it the numbers to do these tests. Okay, is 10 between 0 and 5. Okay, number, low, high. It's 10 between 5 and 10. Is 10 between 15 and 20. Those are the questions we're asking, and we're expecting them to return back as either true or false. And in order to be between a range, it needs to be both above the low end and below the high end. We are asking, or currently it's asking for or. A number is only between a range if it's above the low and below the high. If you have or, that's all numbers. Every number is either above the low end or below the high end. But we want it to make sure it's both, so you need to switch this to an and operator. And then it will check that condition accurately, or the condition it's supposed to be. Is 10 between 0 and 5? It is not. Is 10 between 5 and 10? It is not. And it is 10 between 15 and 20. It is not. I suppose they are going for not inclusive in between, which we could test. I mean, we don't know what they want, but 9 should return true if I do 9 between 5 and 10. But regardless, we fixed it the way it's supposed to be. Okay, so the only change on this entire bubble was the double ampersand. Contains errors. What are my errors? Did I? Is it because I got rid of those other things? Oh, yeah, I did because it's checking to make sure that I actually used all the functions, even though I deleted half of them for explaining. I'll clean that up later. Let's go to bubble 4. Bubble 4. And we're cruising right along. It's fantastic. So we have some program code and one actual function, well, a bunch of return functions. And the function that's due, is this a return? Yeah, there's another return function. It's just longer. And then our console logs are sort of what we're testing to see if those functions are accurate. Or yeah, accurate, complete. Let's run it and see what's happening. So the first one is supposed to return all uppercase. Let's look at what these functions, so they have they're expecting a string, either all consonants or vowels, and then it's also sending a Boolean, true or false, true or false. And if we go up and see where it's being sent here. Okay, well, it is being sent there because it's the function get letters. And the function get letters is it's receiving what type of letter, either all consonants or vowels. And it's expecting a variable, it's expecting a Boolean, it's expecting a either true or false delivered as this parameter, which it's going to check to see if once it figures out which type of letter, upper, lower, all, when it goes into the nested conditional, it's checking whether or not upper is true. Now, you would think, and it works also if you did if upper double equals true, okay, that is a standard Boolean variable, but because upper is a Boolean, it's its own truth thing. You can just say if upper, because we know it's either going to be a true or a false. So that works as our conditional thing. And so we're checking which type of letter and whether or not it's upper. And each one of those 6 possible paths, 3 different types of letters, upper and lower. This is a lot like the rock, paper, scissors situation where we had 3 paths and 2 nested paths in each. Each one of those nested paths will return the result of the appropriate return function. So this function right here, all upper, is a return function that sends back a list of each of the uppercase letters, and it sends it back to this return statement, which gets sent back to where it was originally called. So it's sort of like a double nested situation. If you didn't understand that, that's fine. Let's see what the output actually is. So our first call is supposed to be all uppercase. We call get letters, send it all, the string all to mean we want all the letters, and we want uppercase. So we've been sent back the list of uppercase letters. Good. Second one is all but lowercase. We are getting all the lowercase letters. Great. The third one is consonants true, which is consonants uppercase. We are not getting consonants uppercase. We are getting consonants lowercase. So that's broken. Consonants lowercase. And we are getting, so those are clearly switched. And then the last one, vowels uppercase is wrong and vowels lowercase is undefined. So let's check the low-level return functions. These appear to be right. All lowercase, all uppercase, vowels lower, vowels upper, consonants lower, consonants upper. Okay, so those look good. Let's see if we can figure out the logic. In fact, I'll give you, this is something that is well within your zone of proximal development. You can figure this out. Where is the logic wrong? What needs to be called where? Please try this now. I'll give you 2 minutes at it. As soon as I can start the timer. All right, so we knew the first two worked. We were asking for all, and in fact, I'll just go and bring this up. Asking for all uppercase, we got it. And we asking for all lowercase, we got it. The next one was consonants uppercase. We made it to consonants. The consonants upper is consonants, upper lower is consonants, but they're the wrong upper and lower. And that's because in the nested conditional, when we're checking for if uppercase is true, meaning if we want upper, it says lower. So we just need to switch these two. So we're returning upper when true was sent for that parameter. So consonants upper is good. Consonants lower is good. And now for vowels, we got where we asked for vowels uppercase, we got vowels lowercase. And where we asked for vowels lowercase, we got undefined. So here, again, we're asking for uppercase vowels, and we have lowercase. So clearly that needs to be there and switched. But uppers isn't going to work. Vowel upper isn't going to work because it's not set up as a return. We're just calling this function. This becomes that list, but we're not doing anything with it. We need to ship it back to where it's called, where the return function is called, which means we need to actually return vowel upper. And that, I think, is it for this one. Yeah, vowels upper works and vowels lowers works. All right. And I think bubble 5 is the last one, and then a brief check for understanding, I think. Okay, bubble 5. This program is designed to be a simple list library. Meaning that there isn't actually anything happening here except for the console logs, just like before. And the console logs are just there to test before, and the idea is that this is just a set of functions that are designed to work with any sort of lists. And it is tested by these console log statements. First, let's just go through and make sure they work, which is the point of this. We are trying to debug or pre-debug right as we're working with them. So we have the function called fill that is designed to make a new list that is made up of whatever we want it to be and have whatever length. So when we call it, we need to, well, first of all, it's going to return a list. So we need to put it in a list. So first, let's console log, because that's, no, it's fine. We can console log it. And when we call the function, the result of the return function will be the whatever list we give it, or whatever list we want. So we're going to call fill, and we'll send it, let's say we want a list of 10 zeros. We hit run, and it should print out a well, we've got all those extra console logs, but there we go. We have a list of zeros. You might wonder why that's useful, and it actually is sometimes useful. If you're trying to make a grid of zeros, nested loops, you can utilize that as sort of a two-dimensional, well, that two-dimensional array can represent a grid, and you can switch on and off, replace these zeros with ones to keep track of some sort of event and turn it into a data visualization. Or you could make a list with empty strings if you want to keep spaces open to change things later on. Because if the list is only a few things long, you can't set a property of something in a later position if it doesn't exist yet. So creating a list with one generic property allows you to have a spot at this position that you could change without having created things before. But regardless, we know it works. Write 3 different tests. I don't know. Let's go. Let's have 4 ASDFs, and let's have 11 11s, or whatever you want to test. And there we go. We can make a list. We can output a list of however many anythings with our fill function. All right. So second one, we have a function that's supposed to multiply every number in a list by a certain number and return that updated list. I will give you a minute or two to see if you can figure this out. We have a list. We want to do something to every item in a list. How do you get to every item in a list? We want to replace that item with whatever it's there, multiplied by whatever the other parameter is, by number, and have it replaced with that new updated value. My guess is that you have, well, not my guess. Many of you have the ability to do this right now. Okay, so our goal is to return a list that is the same length, definitely, as the list we're given, except with every number in that list multiplied by, with each number in that list multiplied by the other parameter and returned in a list. So we're going to do something to every item in a list that you should know right away. We're going to throw a for loop in list.length number of times. And every time we get to a new item in list, we want to multiply it by number and put it into our return list, which we can do in a single step. There's no condition needed. We're doing something to everything. It doesn't matter. We want to append something to return list. What do we want to append? The number we're looking at, which is list index I, times the other parameter they give us, which is number. And after we go through each list item and multiply it by number, adding them to our return list, we ship return list back, and this entire return statement becomes that new list. We hit run and multiply 1, 2, and 3 by 2 gives us 2, 4, and 6. Multiply 10, 20, and 30 by 5 gives us 51, 150. And multiply -1, 2, -1, -2, -3 by 3 gives us -3, -6, -9. Okie dokie. So that works. Okay, so this one is another fun challenge, and I'm not saying it sarcastically. I do think this is an interesting puzzle that most of you have the ability to solve this, even though we haven't talked about this type of thing at all, or haven't done an example of this. Your goal, your challenge, is to finish this reverse function named reverse, and the function receives a list, and its goal is to return a list that is whatever list was sent, but in the opposite order. Think about how you might want to do that. And in fact, we definitely haven't talked about what we need to do for this, but I'll give you a minute to fumble through it. Yeah, you take one of the things. There you go. Awesome. Okay, so we get a list, but we want to put that in reverse order. Now, the way you have to do this, you could go through the list in order, and every time you add something, you insert it into the first position, which shifts everything down. So the first thing in there, we go to the first item in our list. Okay, so this is one way to do it. We'll do a loop list.length number of times. And every time we get to an item, we are going to do insert item. The list we want to insert it to is return list. The index we want to set it to, if we want to put every time we get to something in the list, if we go through the list in order, every time we get to a new thing, we want to put it at the front of the list, our new list. We come to the third thing, it goes to the front of the list, and everything shifts down. So we want to put everything in position 0, and the thing we want to put there is whatever's in list index I. Okay, this is one way to do this. I'll show you the other way, which is hold on, return list. I forgot to clear that out. Return list. Okay, reverse 1, 2, 3, 3, 2, 1. Reverse yes, no, maybe is maybe yes. Okay, this is one way to do it. The other way to do it is to loop through a list. I'm going to show you a backwards for loop, meaning we are starting, instead of starting at index 0, we're going to start at index list.length -1. And we're going to go so long as I is greater than 0. We're counting down each time while I is greater than or equal to 0. And every time through the loop, we're not going up 1, we're going to go down 1, which is I minus minus. Okay, this is a backwards for loop. It is used a lot, all the time. It is needed if you ever want to remove, if your function is to remove items from a list, you have to go through it backwards. Because if you go through a loop forward, normally, and remove items, if you get to something where you remove an item, it shrinks the list. Everything moves over, so you'd effectively be skipping an item in the list. So going through a loop backwards is common, in which case we're going through our given list backwards. We can just go to each one and append it to the temp lists, and it will make it or the return list will make it a reverse of the original. So here we're going to send it list index I, whichever one we're checking. We're accomplishing the same thing 2 different ways. So reverse 1, 2, 3 is 3, 2, 1, and reverse that is that. Okay, so either one of those options, either insert to the beginning or go through the loop backwards and just regular append, either one of those works. All right, and the last thing for today is the check for understanding. Let's take a look at it, and then I'll put the code back up. Check for understanding here. We have a practice question with some pseudocode, even though the question is actually in program code, whichever. Okay, the following procedure was developed to determine if a list contains a negative number. If it contains a negative number, should return true, otherwise return false. An error is made writing this function, so it doesn't work as intended. Which line of code would be needed? Which line of code would need to be fixed in order for the function to work as designed? This is a type of question you will see on the exam, and I think it's probably one of the hardest style questions. They aren't asking you to figure out what the result of the program is or what the values of the variables are that you can keep track pencil and paper. They are asking you to internalize this function and figure out which part is breaking it. All right, so the answers are which line makes it not do what it's supposed to. I'll give you a minute to look at it. Work through it and see what you come up with. Okay, check number receives a list. Has negative gets true. All right, we need to wrap this up. Sorry about the extra minute. So the key is that this function has, or not function, this variable has negative, which you know is a variable because it has the variable assignment thing. It's a Boolean variable. It is either true or false. And this function is designed to return either true or false, depending on whether it has a negative number. Boolean variables you can think of as like a switch where the variable needs to be pointed at either true or false. And this one starts out, it pointed at true. Then it goes to each number in the list. And if that number is less than 0, has negative becomes true. And when it's done with that, it returns either true or false, depending on has negative. Imagine a list that has no negatives. It goes through and checks each of those numbers. Each number in the list, if it has negative, if it's less than 0, it's not. Keep going all the way through the list. And we return has negative, having not changed it. it's still pointing to true, even though there were no negatives. If you're checking for something to be true, the checking variable has to start out as false. Otherwise, what are you checking? We're checking to see if there's any negatives. We are starting under the idea that there aren't any. We're not worried about how many negatives. We're only worried about if there are any. So we start out with the idea that there aren't any until we find one, and then it turns it to true. So the problem is that it starts as true, and that is the error here. What are the other options? 6, 9, and 11. Number greater than 0. No, that's not it. You could switch this to negative. No, because we're not checking greater than. We only want a single negative to be negative. So yeah, it's definitely that one. All right, so I'm gonna end the recording, and if you have any questions, let me know.